Hello everyone, back to stoichiometry. In today's lesson, we're going to encounter four new terms: formula mass, molecular mass, gram formula mass, and gram molecular mass. Now, all of these four terms essentially mean the same thing. Each one really is just the sum of the atomic masses of all the atoms present. And that's why the word mass is highlighted in each of the terms, because no matter how we begin the word, it really is just the sum of all the atomic masses. Now, let's break the words down to make sure you understand why we use different beginnings, even though they all mean the same thing. So, formula mass first. When we use this term, we're talking about something that is an ionic compound. And an example might be just simply KCl. And we know it's ionic, once again, because we see a metal connected with a nonmetal, right? They've reached their octet. Now, what's so special about formula mass, it's still the sum of all the atomic masses, but the unit for this specific term is going to be atomic mass units. And that's abbreviated with a lowercase u. And that's what my lowercase u looks like. However, when we change the term into molecular mass, so the word molecular is now highlighted, we're specifically talking about covalent molecules. So once again, scientists make that distinction between something that's ionic and something that's covalent. And that's how important it is to know the difference between something ionic and something covalent. An example might be carbon dioxide. And we can easily see that because we have a nonmetal connected to another nonmetal. And once again, this unit for molecular mass is going to be an atomic mass unit. And it's abbreviated as a lowercase u. Now, changing the terms just slightly, we now have gram formula mass. We still have formula, so it's still going to be ionic. However, we see the word gram in front, and that changes the unit that we're going to use. And this allows us to use formulas in the lab. Instead of using something that's microscopic or macroscopic, we now turn it into grams, something we can use in the lab. So the unit here is going to be grams, and it's abbreviated lowercase g. Now the same deal with gram molecular mass. Molecular implies that it's going to be a covalent molecule. However, we have that word gram in front. So that means that the unit is no longer atomic mass unit, but rather grams. And it's still going to be the same abbreviation, just a lowercase g. All right, so let's take a look at a couple of sample problems. In this sample problem, we have KCl. The first thing you should recognize is that it's a metal, potassium, and chlorine, a nonmetal. So it's going to be ionic. You always need to double check and pay attention to what you always have. This is an ionic compound. Now, in order to help us, we have to kind of go through it systematically. And this is where you're going to need your calculator and your reference table. So pause if you don't have it in front of you and go get it. Now, in order to get the sum of all the atomic masses, we have to do a couple of things from the formula given. The first thing that we need to do is determine what we have. And when we look at a formula like KCl, we know we have potassium and we have chlorine. Once we know what we have, we now need to determine the quantity. And if I look at the formula carefully, there's an unwritten subscript of 1 next to the K and an unwritten subscript of 1 next to the chlorine. I need to multiply the how manys, or the quantities, now by the atomic masses. I'm going to be very specific just so we're all the same. We're going to take the atomic masses to 2 decimal places. So when you look at your reference table, we're not rounding. We're just looking at the little box and finding the atomic mass and taking it to 2 decimal places. So when I look up the atomic mass of chlorine, it is now 39.09. I am not rounding. I'm just taking 2 decimal places. When I look up chlorine, it's now 35.45. So now here it's just straight math. 1 times 39.09 gives me the same value. 1 times 35.45 gives me the same value. And I'm going to take the sum. When I take the sum, I now get 74.54. Now, be careful. If the question asks for what is the formula mass of KCl, you would write 74.54 and the unit must be U. It will be marked wrong if you have the wrong unit because it means you were not looking at the question carefully and listening to what they asked for. But if the question asks for the gram formula mass, my answer now becomes 74.54 grams. Because it asks for gram formula mass, my unit must be in grams. When a question asks for formula mass, my unit must be in atomic mass units. All right, let's look at another example. This time I have CO2. Carbon dioxide is a covalent molecule. I know it's covalent because it's a nonmetal attached to a nonmetal. Now, it is the same procedure. I need to determine what I have. I need to know how much of each I have. And then I need to multiply it by its atomic mass to 2 decimal places. And then I need to sum everything together. So, easily, I have carbon. I have 1 of them. And when I look on the periodic table, I notice that its atomic mass is 12.01. Only 2 decimal places, do not round. I also have oxygen. There are 2 oxygens because there's a subscript of 2. And I'm going to multiply that by 15.99. Once again, I'm not rounding. I'm just taking 2 decimal places. When I multiply across, 1 times 12.01 gives me the same number, but 2 times 15.99 gives me 31.98. I take the sum, and I get a quantity, or a value, of 39.99. Once again, you have to pay attention to the question. If the question asks for the molecular mass, then your answer becomes 43.99 atomic mass units. If the question asks for what is the gram molecular mass, it now becomes 43.99 and the unit must be in grams. It is very specific here. Now the last thing I want you to pay attention to is this formula right here. MnCl2, there's a dot in the center and it has 4 H2O. When you see something like this, this is known as a hydrate. And that dot in the center is not a multiplier. It is just a separator. It allows us to separate the water with the ionic substance. And it allows the water to have a coefficient in front. So be careful. This is not a multiplier. It's only a separator of the formula. But if I wanted to find the formula mass, it still works the same exact way. I still need to know what I have. I still need to know the quantity. I still need to multiply by the atomic mass. And I'm going to take that to 2 decimal places and then find the sum. So it works the same way. So let's do this. I have Mn. I have one of them. And when I check the mass on the periodic table, it's 54.93. Chlorine, I have two of those. I'm going to multiply that by 35.45. Now, the dot is a separator, not a multiplier, but I notice that I have a 4 coefficient in front of the H and in front of the oxygen. So watch what happens. For my hydrogens, I now have 8 of them, and I'm going to multiply it by its mass. And my oxygens, I have now 4 of those, and I'm still going to multiply by its mass. So the math still works the same way. You would just put this into the calculator and find this sum. You end up getting 54.93 here, 70.90 here, 8 here, and also 63.96. You would take the sum of all of it, and your final answer, if I asked for the formula mass, would be 197.79 atomic mass units. Okay, so be careful with the question and the units that you have to put down. Okay, that's it for now. You're going to try some on your own. I'll see you in the next lesson.